Welcome to this video. So in this lesson, we're going to go over the factor and the remainder theorem. Okay, so let's state what these two theorems actually tell us. Okay, so we'll start with the factor theorem. So the factor theorem states that a polynomial f of x, okay, has a factor x minus a if and only if f of a is equals to 0. Okay, so how do you find this a? You simply equate this factor to 0 and then you solve for x. Okay, so we see that in this case, x is equals to a. So if this polynomial f of x has the factor x minus a, then it means that f of a should be equals to 0. So this is what the factor theorem states. Okay, what about the remainder theorem? Okay, so the remainder theorem states that a polynomial f of x, okay, states that if, okay, I forgot the if a polynomial f of x is divided, okay, is divided by, let me erase this, is divided by x minus a, okay, then the remainder is simply f of a. Okay, so if you have this polynomial and then you divide it by x minus a, then the remainder will simply be given by what? F of a. Okay, to be given by f of a. So if this polynomial has a remainder when divided by this, okay, then it means this is not a factor here. No wonder we are not equating this to 0 like we did here. Okay, but if this is a factor, then it means when you substitute that a there, it's going to give you what? 0. So these are the two theorems that we are going to work with in here. Okay, so now let's look at the questions that we have here. Let's look at the questions that we have. So the first one is 14. So 14, they're saying x minus 2 and x plus 3 are factors of this polynomial here. Find the values of a. Okay, so we're going to come up with two equations, one for this factor, the other one for this factor, and then we're going to solve for the values of what? A. Okay, so let's separate the board into two parts. So we're going to say this x minus 2, we equate it to 0. It means x will just be equals to 2. Here, this one, we equate it to 0. It means x will be equals to minus 3. Okay, so that is what we have. And then now, let's find p of this, because this is p of this, and p of that. Okay, but we know that since this one, they've said it's a factor, then p of 2 is equals to 0. Okay, this is p. And even here, p of minus 3 should be equals to 0. So I'm going to say 0 is equals to, and then in this equation, wherever there's x, I'm going to put 2. So it will be 2 to the power 3 plus a, 2 squared, plus b, 2 minus 12. So what I get is 0 is equals to 8 plus, this will be 4. So 4a plus 2b minus 12. This gives me minus 4 if I combine 8 and minus 12, plus 4a plus 2b. So this will be 4a plus 2b is equals to what? 4. Let's divide everything by 2. We're going to get 2a plus b is equals to 2. So this one here will be our first equation. Yeah. Then let's find our other equation. So we're going to say 0 is equals to, and then wherever there's x here now, we're putting minus 3. So minus 3 plus a plus b minus 12. So here we are going to get what? Minus 27. Then here it will be minus 3 to the power 2, that is 9. So that will be plus 9a, and then here to be minus 3b minus 12. Okay, and then from there, it means we can combine like terms. Okay, so we have 0 is equals to this guy minus 27 and minus 12. They're going to give me minus 39. So I have 9a minus 3b, then minus what? 39. Okay, that's what I'm going to have there. So from there, we can take this guy to the other side. Okay, so that we become 9a minus 3b is equals to 39. And then divide throughout by 3. If we divide throughout by 3, I'm going to have 3a, okay, and then minus b is equals to, if I divide this by 3, I'm going to get 1, 3. So this here is going to be our equation, what? 2. So we're going to solve this equation here and this one simultaneously in order to find the values of a and b. Okay. All right, so here, let's express it in terms of b. We're going to say b is equals to 2 minus 2a. This one, okay, we take the b that side, we'll bring the 13 this side. So it will be b is equals to 3a minus 13. Okay, so we see b is equals to this, b is equals to that. So we can equate this and this. So it will be 2 minus 2a is equals to 3a minus 13. And then, okay, like terms together, we can say 2 plus, this one here will be 13 is equals to 3a plus 2a. So we're going to have 5a is equals to, here we're going to have 15. So divide by 5, a is equals to what? 3. Okay, so a is equals to 3. What about b? Okay, so b, we can use any of those two equations there. So we can say b is equals to 2 minus 2, then 3. So this will be 2 minus, this would be 6. So this will be minus 4. What if I use this one to be b is equals to 3, then minus 13. So this will be 9 minus 13, which is also minus 4. So it means we found the values of a. Okay, so it means the values of a and b are just a is 3, b is what? Minus 4. Okay, so that's how we can find those. Okay, let's look at question 15. We're just still using the factor and the remainder theorem. Okay, so question 15, they're saying when a polynomial, okay, this one here, is divided by x minus 3, it gives a remainder of 8. Okay, so this is specifically the remainder theorem. So if we divide this guy by this factor, okay, we're getting the remainder of this. So we can equate the x minus 3 to 0, and then so forth. We equate the x minus 3 to 0, and then so for x. So it means our x here is 3. So it means p of 3 should be equals to what? The remainder here that they gave us, which is 8. Okay, so now let's find the actual p of 3 by substituting wherever there's x here, we put 3. So it will be 3 to the power 3 plus 3 squared, okay, plus 8, 3, plus k. So when I substitute 3 here, should give me what? 8. So I have 27 there. Even here to be 27. Here to be 24 plus k is equals to 8. So this would be 54 plus 24 plus k is equals to 8, which will mean k is equals to, this here is going to give me 78. When I take it to the other side, to be minus 78 plus 8, so it will mean k is just minus 70. Okay, so we found the value of k, which is just minus 70. Then the next question is find the remainder when the polynomial is divided by x plus 4. So x plus 4 simply means our x is minus 4. So we substitute minus 4 into this polynomial here. But we know the value of this k is what? Minus 70. So we're going to say p of minus 4 is equals to minus 4 to the power 3 plus 3 minus 4 squared plus 8 minus 4. And then where there's k, we put minus 70. So it means what we're going to have here is, okay, minus 4 to the power 3, it's minus 64. Here to be minus 4 squared to be 16. 16 plus, 16 multiplied by 3. It's going to give me 48. Okay, it's going to give me 48 there. So I'm going to write plus 48. And then here to be minus 32. Then minus 70. Okay, so when you combine all these, you're going to get 118. So 118 minus 118, okay, is the remainder when this polynomial here is divided by x plus 4. Right, so that's how we solve that one. Let's solve the last one for this video. So 17, they're saying let f of x be equals to 3x cubed plus 2x squared minus x plus 6, okay? Divide f of x by t of x, which is given by 2x minus 3, and then write your answer as f of x is equals to the answer that you get once you divide this polynomial by this, okay? Then multiplied by this same t of x and then plus the remainder. Okay, so there we are going to use long division. Okay, so we're going to write it like this. So we have 2x minus 3, and then the polynomial is 3x cubed plus 2x squared minus x plus 6. Okay, so 2x into this guy, what are we going to get? Okay, 2x into that guy, what are we going to get? So if we divide 2x into this, we're going to get 3 over 2 and then x squared. Okay, that's what we're going to get. 3 over 2, then x squared. So it's like this, 3x to the power 2, power 3, and then we divide with 2x. Okay, so it means 3 and 2 divide, quite all right. And then these ones here have the same base, and then they are subtracting. So we're just going to say 3 minus 1. No wonder we're writing x squared there. Okay, and then from there, what do? We just multiply. So this whole thing here multiplied by 2x. So we have 2x like this multiplied by 3 over 2 x squared. So it means this and this will cancel. And then 3 and x squared will multiply. I'll get 3x squared. Okay. All right. And then now I multiply. Okay, let me first cancel those yellow circles. Okay, so it means when I multiply here, I'm getting back my 3x to the power 3. So minus, and then this multiplied by this. Okay, so it will be minus 3 like that, multiplied by 3 over 2 x squared. So what are we going to get there? Okay, we are going to get minus 9 over 2x squared. So I'm going to write here minus 9 over 2 and then x what? Squared. Okay, and then from there, what do? Okay, from there we have to subtract. Okay, we have to subtract. So when we subtract the first one, we're going to get 0. And then here it will be 2 minus, this is minus, and then minus 9 over 2. Okay, so this 2, we can also write it as 4 over 2. Okay, so 4 over 2 is the same as 2. So I just want them to have the common denominator. And then with this minus, this becomes 4 over 2 plus 9 over 2. So they have the same base, so we can add whatever is on top. So that gives me 13 over 2. Okay, so plus 13 over 2 x squared. That's what I get. Okay, and then from there, let's divide. So we are dividing this 2x into this guy. So I have 13 over 2x squared. Then I'm dividing this thing by 2x. So dividing by 2x is the same as multiplying by what? Okay, it's the same as multiplying by 1 over 2x. Okay, so if I multiply like that, it means this x is going to cancel one of these x's, and then 13 multiplied by 1, I get 13 divided by, okay, uh, remember there's one x here, so 13x, and then 2 multiplied by 2, I get 4. Okay, so when I divide this 2x into this, I get plus 13, okay, over 4x. Okay, so that's what I get. And then from there, I just have to multiply. So this whole thing multiplied by 2. So it is 3 over 4x multiplied by 2x. This is what I have. Okay, so this is my x. So you can say 2 cancel, 2 there, 2. So 13 multiplied by x multiplied by x, I get 13x squared divided by 2. So it's the one that I'm going to write here. Okay, and then from there, we'll just go step by step. Okay, this 13 over 4x multiplied by minus 3. So minus 3 multiplied by 13 over 4x. What are we going to get? Okay, what are we going to get there? So there we just have to multiply the 3 and the 13. Okay, so minus 3 multiplied by 13, it will give you minus 39. Okay, and then we have over 4 and then x. So we can drop down this x minus x, and then here we say this multiplied by this is giving me minus 39 over 4x. Okay, and then from there, of course, since this is long division, we have to what? Subtract. So these are the same, so it gives me 0. So I remain with minus x and minus 39 over 4x. Okay, so it is the coefficient of this is just minus 1 minus, which is this one, and then minus this. So since it's a minus, so it becomes positive 39 over 4. This one here is the same as 4 over 4 like this. Okay, so the denominator is common, and then I have minus 4 plus 39. So this will be 35 over 4. Okay, so when I add here, I'm going to get plus 35 over 4x. Okay, and then from there, what do? We divide again. So 2x into this. So we have 3, 5, 4x divided by 2x, which is the same as multiplying by 1 over what? Let me use this, which is the same as multiplying by 1 over 2x. So what we see is the x and the x, they cancel. 35 there, get 35 divided by 4 multiplied by 2, that would be 8. So this divided into this will simply be plus 35 over 8. Okay, and then from there, we just have to multiply now. This 35 over 8 multiplied by this 2x. Okay, so 35 over 8 multiplied by 2x. So 2 there, 1. And then 2 there, 4. So what we have there is 35x over 4. So I'm going to write here 35 over 4 and then x. Okay, then I can drop down this guy here, which is plus 6. Okay, and then I can multiply now. This 35 over 4 multiplied by minus 3. So what do we get there? Okay, so just multiply 35 multiplied by 3. I'm going to get minus 105 divided by 8. So minus 105 divided by 8. Okay, and then of course there, we just have to subtract. Okay, so when we subtract there, I've run out of space going down. Okay, so I'll just continue from here. So let's say this is this line, the red line. So if I subtract here, okay, if I subtract here, what am I going to get? I'm going to get 0 because this is the same thing minus the same thing. And then here I have 6 minus this minus, and then minus 105 over 8. So it is 6 plus 105 over 8. Okay, so you can add these. Okay, you can add this. So this 6 is the same as 48 over 8. Okay, so 48 over 8 is the same as 6. So this 6, I'm going to write it as 48 over 8, and then 105 over 8 as well. So 48 over 8 plus 105 over 8. So what I get here is just 8, and then here to be 105 plus this. Okay, so 48 plus 105. I'm going to get 153. Okay, so 153 will be our remainder. Okay, so now let's arrange our answer in this format that they said here. Okay, remember what we have under this root here is our f of x. Okay, what we have here is our t of x. The answer that we get on top here is our q of x. And then the remainder, which is this one, is our r of x. Okay, so we can express our answer in that form now that they wanted. Okay, so we're going to say f of x is equals to, maybe I should write the actual things. Okay, so we're going to say f of x is 3x3 plus 2x2 minus x plus 6 is equals to the q of x, which is this, plus 35 over 8. Okay, and then this thing here, we are multiplying it by t of x. So let's erase this 153 over 8. Okay, this was the remainder. So we are multiplying this q of x with the t of x, which is 2x minus 3, and then plus the r of x, okay, which is what? The remainder. So the remainder is just 153 divided by what? 8. Okay, so now we've arranged the equation in the way that they wanted. Okay, we've arranged the equation in the way that they wanted. Because this is our, okay, let me use a different color. This is our f of x. This here is our q of x. This here is our t of x. Plus, this is our r of x, the remainder. Okay, hence we are done. Right, so thank you so much for watching this video. If you'd like to access the full solutions to the tutorial sheet that I was solving here, please feel free to check the link in the description to our website.